right away starting the session. Yeah. Hey guys, this is Nilesh. So we have today a data science demo, and I believe you guys have any basic idea what's data science, why we are using this applications, and before talking about data science, since it's a solution, we need to understand the problem statement. Because data science is not something which we get in 5 years ago or 10 years ago. We are working with this since very long. I'll tell you that definition, description, everything about it. So we'll not discuss much on the theoretical part today. I'll try to implement or use some real-time applications where we are using this data science methodology. Any question, if you feel guys, you can note down somewhere or you can write me on the chat window. And once the session is over, we discuss all the points. I'll start answering your questions one by one. So can I get the name? How many people have joined? Just name and their working guys. What you do? It will give me one understanding that which scenario I need to pick up.
Amol, can you, Shubham, can you quick intro a background experience and your agenda for this demo session?
Okay.
Hello.
Yeah, Amol, please go on.
Hello, sir.
Yeah, Amol, I'm hearing you. Please go on.
So actually, my background experience is in the service field in the pharmaceutical instrument.
Mm-hmm. Okay, and you're involved in a technical work or you're doing some non-technical work?
Technical work.
It's a
technical work.
Okay. Which technology are you working on?
Technology. This is not IT. Actually, this is a imported instrument. We are selling to the particular pharmaceutical industry, and we provide this service, installation, breakdown, and all these things.
Okay, perfect. So what is the in general expectation from this demo class? So you want to focus on which side? Since you are in healthcare domain, so myself, I'm involved in healthcare domain. I'll tell you where we are using this in data science applications.
Okay. Actually, sir,
Yeah, Nikhil.
Actually, I just knowing the what is a data science, what is a use, and what is the future scope in this field.
Okay. Perfect. Yeah. So thanks for your intro. Vama, do we have anyone else?
Shubham.
Shubham, yes,
Hi, I am 2018 BTech pass out, and currently I am working in Atos. I have 1.5 years of experience, and I have worked in two projects. One is of production support, that is on .NET and SQL database, and another is manual testing project. Okay. And it is a bond of 2 years in my Atos. So after the completion of that bond, I want to switch in data science field. That's why I have joined this. That's why I want to join this class.
Okay, and any basic ideas, Shubham, what is data science, why we are using, why we're talking about so much this tool technology?
I have not much idea, but data science is related to data in which we analyze the data and how it is utilizing by any person. It's all about that, and we use in that mathematics and statistics.
Right. Finally, so I have collected your inputs. Based on that, I'll start this demonstration. So thank you all. Let's start this. Any question comes, let me write me on this chat window so that I can see your questions and answer accordingly. So let's see what are the things we have involved in a data science. When we say data science, it's a package, but package of what? Now, if you ask me, since when we are talking about this technology. So the year is 1938. You must be amazed that why we are working with data science applications. So people who are not talking, can you please mute themselves so that we can have a interactive session. Any question comes, you can again unmute yourself. But till the time the session goes on, please mute yourself. Thank you. Why we're talking about data science mainly after 2010. So I'll give you the reason for this. Because before going to the data science, we need to jump into the big data side a little bit. And we will first understand this problem statement, because in general, I'll call technology, language, it's a one kind of problem statement, and this problem is exponentially growing. I'll tell you due to what. Now, when I say big data, please mute yourself. There is some coming from your side. Ram, are you there? Hello.
Yes, I'm there.
Please mute yourself. There is an
Amol, can you mute yourself? There's some background noise there.
Yes, sir.
Just kindly mute yourself. If any question, you can come on here and ask a question. There's some background noise coming from your end, I guess.
Okay. Take it on.
Thank you.
Yeah. All right. So let's discuss this problem statement. We got this term in 2005, and there are multiple firms, IBM, Google, O'Reilly Foundation. They started talking about this big data. And what is the definition of big data? Like in plain layman terms, if you ask me. So massive volume of data, humongous data set, huge volume, we consider it as a big data. But in today's generation of data, we do not call any more big data, we call them a fast data. And if you go to the number and see all possible data across the globe, which are obviously online internet data, weblogs data, satellite, interceptors, radio frequency. So I'm talking about the unit here. What is the total volume? And that volume is 0.6 zettabyte. Now, if you ask me what is a zettabyte, so let's go and understand data journey. Right. Now, one zettabyte is equal to 10 to the power 21 bytes. It's a huge and massive information. After 2006, again we check this in 2012, and this number was 7.5 times multiple, which was 4.4. And let's see how many different unit we have in the data set. So it started from tiny bits to nibble, to bit, bytes, KB, MB, GB, TB. This is pretty common. Everyone knows what is terabyte. Beyond terabyte, there's a petabyte, exabyte, zettabyte, and highest unit which we have today is a yottabyte. Okay. And this data is exponentially growing, because you cannot say after 2 years, 3 years, or 5 years, data generation rate will completely stop. Just like the population can never stop, the data generation rate will never will stop. And by the time in 2012, Google team made a prediction that after 8 years, what would be the volume? They get another number, and it was 3 times than the previous year, 2012. In 2017, again we made a prediction, and that prediction is saying by 2025 will be somewhere on this number. So question is not data. Question is, who is generating this data? These are coming from which industry? Are we people involved to generate this data? So we can now talk about multiple sources, not just one. And obviously, when I start talking about data, my first input is social media. Now, I'm not just talking about the giant one, which everybody knows, Facebook, but there can be ample of other forms like Twitter, Instagram, Flickr, Snapchat, WhatsApp, YouTube, etc., where people can exchange their communication. Now, since 2012, Facebook is claiming that per day, every day they are storing 512 terabytes data, which they say half a petabytes. and in a single month they store 7 to 8 petabytes of data. So currently we are learning, understanding the problem, and then we'll go and see the solution, how this problem can be tackled using different approach. 7 to 8 petabytes per month, this data they are storing, and these are just images, guys, pictures which we people, society, individual upload in a Facebook repository. So if you just give a round of thought here, Facebook is not a first social media. Earlier, 2010 and 2006 and 2008, we had other social media services like MySpace, Yahoo Messenger, Orkut, but data generation rate was very, very low. As you can see the number here, 0.6 zettabyte. So what can be the reason? Today, if you ask me, the total world population is 7.8 billion. And out of this number, 1.3 billion people visit internet per second. So you can see how many log file we are generating in a second wise. So per second, I'm generating 1.3 billion log file, cookies, cache, and we need to understand this data, because just to storing data, streaming them, exchanging from one platform to another platform is not really helping me in any terms of business use. So I want to use the most out of this data so that I can increase my revenue, business understanding, forecasting, and XYZ. Yeah. Second reason can be internet penetration, definitely, because if you go and see in 2006 in India itself, we had definitely a good population, but number of internet users were very, very less. Today, everybody is having a smart devices. You travel anywhere, you stop from your vehicle, start taking pictures, but what exactly you do? You go to social media, start uploading them. This is how the data of cloud is increasing. Now, next we'll see how this data is helping us. So second reason, or business domain, I'll take as a stock exchange, stock market. In India, we have NSE and BSE, National Stock and Bombay Stock. In US, we have a New York Stock Exchange, and their data generation rate is 4 to 5 terabytes per day. And every day, 1 TB is a new data set out of this number. The question, how this data is helping me? Let's go to the real-time scenario. If you guys are involved in any stock exchange, you guys do any, you invest there, right? In NSE and BSE. So what exactly do, suppose I'm targeting any item, which is X item, X product. And today the price is 100 rupees here. Now, somebody, financial expert, so maybe I'm watching any business channel, which is G Business or CNBC, their financial experts are sitting and they start talking about this item. They say after 20 days, which will be say 11th of April from today, this product will get 15% hike. So we'll see the immense growth on this product, which will be 15%. Now I'm definitely putting my hard-earned money, so I need to think 10 times that is it really going 50% high, or it can go 10% down also. How do we know that? So multiple factors are involved to understand this prediction. Whenever somebody says after tomorrow, after 1 hour, this will happen, in theoretical modeling word, we call that as a prediction, because prediction can never be 100% accurate. If prediction start getting 100% accurate, which means you know the future. So this is very difficult. Even companies such as Google and Apple also, they say we are 99% accurate. We are not 100% accurate. Yeah. And let's take a general scenario. Say I give you 1 year of data. I'm asking you what's your prediction. You said your prediction is 12%. This data can be from any business domain, guys. I'm not specifying this is only social media data. This business domain can be anything. Trust me, banking and e-commerce are the one who started working with this big data at very first place after 2008 and 2010. Till the time world was not even knowing what is a big data and what solutions we have. Nowadays, telecom, healthcare is a very new industry into this. So online digital healthcare. We can say retail shops.
Nilesh, sorry to disturb. Two people joined, Sri Krishna and Anuja. Guys,
Okay.
you're audible? Sri Krishna, Anuja, you there?
Yeah.
Okay.
Krishna, yes, sir.
Okay, thanks, Anuja. If any question, you can come on here. So we just started 5 minutes paper. Thank you. Continue, Nilesh.
Okay. Okay.
Yeah. So guys, Anuj and Krishna, we have not started any applications of data science. We're only understanding the problem of problem statement which is coming because of big data and some other data channels and data journey. Now we need to see the solution. So let's understand the problem statement and swiftly we'll move into the solution, how we are tackling them, how we're handling them using the distributed computing, parallel processing, prediction concept. We're talking about the data business domain. This data is generating from how many industries? So I'm currently into that topic. So advertisement firms, logistic companies, I can say, travel industries like Uber, Ola, food industries, Swiggy, Zomato, media services like Netflix, Amazon Prime, Hotstar, Reliance Entertainment, and etc. So these are different business domain. Even today, matrimonial sites also started coming into the site. So simple reason, guys, if I have more variety of data and I have more volume of data, very simple, I need a smart solution which can complete my business execution as early as possible, and hence I need a smart solution. So we need to talk about the edge technology after this. Second example I have taken as a stock market. So I was saying, if you have 1 year of data, your prediction rate is 12%. Say I gave you 10 years of data, and again this data can be from any of this domain. Okay. Be with me. I'll complete these applications where we are using in a banking, e-commerce, and all of this. So say 10 years data you receive, and your prediction rate is now 45%. And now I'm giving you 100 years of data, and question remains same. This time you're saying I'm slightly better, even more closer to 100%, and my prediction rate is 100%. So looking at this number, can we make one conclusion? Can we make one conclusion that data is directly proportional to prediction rate or accuracy? The more is data, the more is prediction. Yeah. And why data science and other edge technology was not very much hot topic before 2000 or 2005, because this term itself we get in 2005, and since then we are checking the data volume. Now in last 2 years, from 2017 to 2019, you know how much volume we have stored across the globe is 90%, which means before 2017 only we had a 10% data, and most of the data was a structured data out of that. So if data itself is not available, then how can you analyze it? So first, a strategy here to store the data. Once you store, then you can start analyzing them. So we need to find out the storage platform here. And after different sources, if you ask me, what is the category of data? So little bit of technical I'm going, and I'll just write a couple of names here so that we can see this data, if you have gone through, coming under which category. And here we have structured category, semi-structured category, and unstructured category. So these three categories are there. Structure all the data which are part of relational database management system: Oracle, MySQL, DB2, Teradata, Ab initio, MicroStrategy, Netezza, etc. So why we are calling this data is a structured or traditional data? Because they follow a predefined schema. I can create a table, but I'm bound to give the similar data value. If it is an integer, I cannot define the float thing. So if I say real-time table creations, let me create a detail statement. I'm doing this in any of the database, so excuse me for the syntax because it can be from Oracle, MySQL, SQL. I'm creating one table, and with the name called cust. Here I said my cust column is having ID. Table is having ID first column, and second column is a name. And then I'm trying to execute this statement. It throws me exception saying that what is the data type of this column? So ID is followed by integer, name is followed by variable character, string, char. I can use any one of them, and I'm fixing the length also. Now my table can be created. I'm about to perform DML operation now, data manipulation language. And here I'm saying insert into cust values. And then I'm just passing one value and trying to execute this statement again. Again, it throws me exception saying that one is mapped with ID, but what about name? Maybe while defining the table, I can say this is not null. But in current scenario, I need to pass some value, which is a blank empty value. Now my execution can be done. Third problem, if I'm trying to insert other values, insert into cust values. again my table in values, and this time it's getting autocorrected. I said now I want to store the double values on this integer. Again, this throws me exception. So we have so much limitation on this RDBMS side. Semi-structured data is CSV, comma separated value, tab separated value, JavaScript object notations, XML. They comes under semi-structured. Some data is readable, some is not. Unstructured, this is having the white category: text, audio, video, images, log file, satellite, interceptors, clickstream, weblogs, crawling data, right? So RFID, radio frequency information, all this comes under unstructured. The interesting part is this: earlier we spoke about data volume in 2012, and that was 4.4 zettabyte. So out of this number, only 20% data is a structured. 80% data is a combination of these two, semi-structured and unstructured. This is where my problem statement started. If I'm unable to store the data, because if I'm sticking my solution till RDBMS only, I'm about to handle just 20%. How about 80% of data? Because if I'm unable to store them, then my second activity, which is a processing part, analyzing part, I cannot do this. And hence you are talking about artificial intelligence, deep learning, Hadoop, Spark, different ecosystem of Spark, Splunk, this all Apache tools, technology to handle this problems. But our agenda is to discuss more and more on the data science. So I'll skip that Hadoop section and other part. But yeah, just to tell you where we are using this Hadoop, I'll say nowadays this is mainly important for storage of the data. They're providing storage and obviously the parallel processing. So the concept of parallel processing we get from here only. Data science is having a combination, and we know the foundation year is 1938. Since then we are talking about data science. It's a pre-computer era, guys. And package wise, the most important part is going to be this: statistics. And if you ask me what is the ratio of statistics in a data science, I'll say 80%. If you don't know Python, if you don't know any programming language, that's not a problem, because programming language is changing every year and now and then, like 3 years, 5 years, 10 years, but the concept of this can never change. And in Python today we're writing, maybe in future Python can be exchanged or replaced by Julia or some other technology. But what logic we are using behind the data science, because why I'm focusing on this part more, you type today in Google how to become data scientist, you see learn Python, become data scientist, because Python is having all the libraries predefined. I'm not denying that today it is not possible. Today definitely you can learn, but what after 3 to 4 years if it changes, and again you need to learn the new tools and technology. So please focus on this, because all model algorithms are having prior concept of statistics before having them in a Python. So it's like if you're so good in states and I give you some sample data set, 10, 20 data points, you can take a pen and paper and solve without using this. But yeah, obviously if I give you 100,000 data points, you cannot solve them manually using one by one. That's why you need some set of instruction where you can pass to read the data and process them. And hence we need to know one programming language. Today it is Python, or you can use R also. But yeah, states, I'll take you through what different data points, what different analogy we're using. Third is a machine learning application. Excuse me. Machine learning application, and I'll take you through the difference between artificial intelligence, machine learning, and deep learning. Are they coming from the same family, or are they different topics at all? Third is a deployment. So deployment we are doing in a cloud computing, and this deployment can be achieved by Amazon Web Services. Highest number we are using the services today, if you check based on company. Second can be Azure, Microsoft Azure, and third we have the GCP platform, Google Cloud Platform. Let's see statistics. So when I say statistics, again it has two different types. If we segregate them, we'll get 2 points. First one is a descriptive statistics, and second one is a inferential. And in descriptive statistics side, we mostly talk about 6 to 12 grade maths like probability, permutation, combinations, normal distribution, Gaussian theorem, empirical rule. There are 100 different types of distribution. So what this distribution helps us to perform, population distribution, frequency distribution. So distribution is not, any proving anything that LHS is equal to RHS or we are getting some solution. Because if you ask me, do we have any perfect or right solution in the data science? There is no any right solution. We are not proving anything that LHS equal to RHS. We just need to get the better and right approach. So definitely it can be one scenario that I'm giving 100 data points to all of you guys, but all of you having a different accuracy in predictions, because we are not following any ready-made methodology, ready-made tools. We need to understand so much of prior concept before moving to the models, because trust me, implementing the model is just a 10 lines or 50 lines of code. It's very a seldom approach. I believe that we are writing 100 lines or 200 lines of code. So writing, it's not you write 100 lines of code and become a better data scientist. You need to understand the data exploratory part first, and second is the domain knowledge, obviously, because you're trying to make one model which will act as that guy, act as that domain expert, right? So distribution is nothing but a theoretical modeling. We prove that this can happen because let's say you go to the scenario such as 1950s. So 1950s, if you say how a civil engineer used to build dams, right? So if one civil engineer is building a dam in pre-computer era, how they used to do this, because that time data collection was very difficult. So that time they used to perform this theoretical modeling, use some prediction concept, use some typical charting methodology, and get to know the solution. And obviously by the time we had hardly a data point. Suppose to make one new design of the dam, I have just a 200 data point. So if I have just 200 data points, I cannot rely on the probability very much percentile concept. I need to prove on this based on the distribution, because here, if my all the data point is fitting well, I can say this distribution is coming from this method. So descriptive is again here one third of data science is based on this random variable, and this random variable has a two separate part. One is a discrete random variable, and I guess we all know what is a random variable. Like X can be a random variable, or maybe I'm writing one algebra, so I'll be using a couple of mathematical terminologies here, so please be with me. 2x plus y I said, and x and y if I'm asking what exactly these are. So these are two different random variable. So currently I'm saying x is my random variable, where discrete is one type of random variable and second is a continuous. In machine learning chapter, this discrete is known as a, so we are using the exact concept of random variable. And trust me, 33.3% of machine learning is based on this two, discrete and continuous. Discrete is known as a classification methodology or classification concept, and this is a regression concept. So if you just read a data science article, definitely you will find these two terms. But we're not discussing here any technical or theoretical concept. We are here to understand the practical implementations where we are using this discrete maths and continuous maths. Let's take an example. So we have a fair coin. We have a unbiased coin, and I flip this coin. One time, and I'm asking you what is the percentage or probability to get head and tail. So everybody knows that this is a uniform kind of distribution because I just flip one time, and the percentage is going to be 1/2, which is 50% for each, right? It's not I can say I get 0.8 times 80% times head or 20% time tail, like unlike a coin up Sole movie we have seen in the past days. Second can be a dice example. So say we have dice number written already in the cube, and that is 1 to 6, right? So 1 to 6 number is there, but if I throw a dice and I'm asking you what is the probability of getting any number, all should have an equal probability, so answer should be 1/6. But can you tell me that we can get 4.5 also? Like in between 1, 2, 3, 4, 5, 6 number, there's no chance to get the 4.5. There's a fixed value defined already, and hence we call this is a discrete data. In other words, you can call data which are finite is a classification data. Continuous means I'm saying in one area we have a huge gathering and we have millions of people. Then we take some sample from them, 500 sample, let's say, and I am asking what is the average weight, what is the average weight, or maybe what is the average height, what is the average salary. We can take any of this example under continuous: average weight, average salary, average height. Yeah. And if it is the average weight, yeah, so average weight, I have taken 500 sample. Can you tell me that this average will be 45.8 degree only, or per person weight will be 48 or 50 kg or 60 kg? We cannot say that number. We will fix the interval here, that minimum can be 40 kg, maximum can be 110 kg, and this number can be anywhere in between this. Unlike the example of dice and fair, we had the fixed value here, but we do not have any fixed value here. If you're forecasting any rain percentage, water total number of water we are going to have in inches tomorrow, next day morning, right? So this is all forecasting, this is all predictions, and you cannot get to know the exact number, and hence we call this is an infinite data sets. This is a regression data set. And what method we use to solve this problem in typical maths? We use the calculus, we use the integrals to solve this continuous mathematics problem, right? But where we are using this in a real-time applications. So real-time application wise, if we go, I'll say we are using this in the real estate, we are using this in the loan approvals, we are using this in the fraud detections of the banking industry. Then we are using this to the insurance policies, which what premium we should calculate and give it to the customer aged between 30 years to 40 years, 40 years to 50 years, 50 to 60. After 60, we don't have any insurance policy. I'll take any one of example here. So how we are using this in a real estate world, right? So we are a common person. We want to know the price of our location. We say we want to invest or we want to get a house. So what are the information you're looking for from your property consultant or any of these websites which are quite popular in India? So Magic Bricks, we have 99 property, we have Common Floor, we have No Broker, we have, and etc. Right? So you're going to these websites, maybe you are submitting your requirement that how much area is required, how much BHK you need, how much what should be your house age, whether it should be a new house or old house. What is the location? Very important. And based on this, you're saying what can be the price. Now in statistics world, we call this all area, BHK, age, and location. These are my X. So why I'm noting this value as a X? Because all they are independent values. All they are in statisticians world, we call it's an independent variable, or in mathematicians you can call it a vector, it's a 1D array, it's a kind of data points. So we have a different domain knowledge needing for data science, and hence we can have a different names for the single word, different terminology. So do not confuse there. Independent variable, why I'm saying, because they all are independent to each other, they're not adding values here. So we can check the covariance also, whether they are going to positive or negative. Based on that, I can check the price. And what is the price here? So price is often referred as Y, and this is a dependent variable, guys. Because roughly, can you make one statement that this price is dependent on all of this? So based on this only, we need to predict the price. And to calculate this, in common scenarios, you are calling to this executive, you are giving your requirement that I need 1200 area, I need 3 BHK house, I need 0 years old house, which means it should be very, very new. And I need this house in location of Delhi. So you can give any Delhi location there and tell me the price. They will check their catalog. Maybe they're reaching back to you after half an hour, 1 hour, and telling you the price. But by the time maybe you're busy, not able to answer the call, their executive can call at a time only one person. So obviously it's a manual approach. You are checking by yourself manually, they're calling you manually and getting the things done. In single word, what data science is bringing to us, it is converting your manual approach into automation. So I want to build a scientific process where I will train my data points, where I train my different values, vectors, all the arrays, and then based on that I will fit that model. When I say model, it's an algorithm. It's one set of algorithm which I'm trying to write using one programming language and fit into the concept of machine learning. That's what is a model, and I'm bringing the automation approach. Now how I'm doing this? So maybe I have collected 10,000 data points from all of this different website which I have written at top. So I have collected 10,000 data points, and I decided that I will split this data. I will split this data into two parts, 80% and 20%. Okay, 80% data I'm giving it for training. Training means I'll say if this is the area, BHK, age, and location, this is the price. So which means I can say this is my data which are already available from Delhi. I have collected last 10 years of data and collected 10,000 data points. So can I say I'm dealing and working with a historical data set? And whenever you work with a historical data set in machine learning, this concept is known as a supervised learning, where data, all the data is labeled. All the X, all the Y we know. This X is helping us to identify the Y, or how many best X is important. Okay, so 80% I'm keeping for training and 20% I'm keeping for testing. Once I train, I will store that reference model somewhere in my reference variable, and then I'll pass this 20% data to test the accuracy. This is like, say I have 100 different questions from one topic, one model, and I'm training a guy, I'm training a small kid. Okay, let's understand the scenario. And out of 100 questions, I just have given 80 questions, and 80 question answer is also known to this kid. 80 question answer is also known to this guy. He learned so well, and after a month, I decided to take a test. And here I gave 10 question, or let's say 20 question, because I had 100 question, and out of 20 question, he or she is able to answer 16 question. What is his or her accuracy? 16 by 20, because 20, this question right answer is with me, and 16 question is the right answer given by this kid. So 4 questions is wrong if I compare this 20 answer and this 16 answer, and I can know that it is 4 by 5, which means our accuracy is 80%. This is how do we check? We need to split the data set and give one number. So this is example of real estate. You can apply this whole concept in other methods also. Like suppose I want to check the person is diabetic or not. So when you say the person is diabetic or not, it is yes or no. Whenever you see 1, 0, yes, no, true, false, this is all discrete maths. We have seen it, right? If the number is finite, the number is known. So a couple of applications which we're using in a classification side. So this application is what? If I'm asking the person is having diabetic or not, should I approve loan? Yes or no? Should I pass the insurance? Yes or no? Should I buy a car? Yes or no? So whenever there is a yes and no thing, this is coming under classification. And in classification also we have a type. So this classification is known as a binary classification, because you have only 2 things, whether to predict yes or no. We have other data type, other 2 different classification also, but those are coming under different machine learning algorithms. So I'll just write a name here. We have a multinomial classification and multinomial. It's not nominal, multinomial. And third one is ordinal. So multinomial data looks little weird. Like I want to compare between 3 cities: Pune, Delhi, Mumbai. This type of data is a multinomial because I don't know based on what value I should keep the first Delhi, second Pune, third Mumbai, or what should be the order. Here ordinal means you deal with a low, medium, and high. This can be a ordinal. My machine knows that if I encode this value as 0, this value as 1, this value as 2, so my machine will understand everything better, because anytime 0 is less than 1 and 1 is less than 2. But if I encode this value as 0, 1, and 2, based on what I'm saying that this is 0, 1, and 2. And why I'm doing this, because I'll make a note here. Machine learning does not understand machine learning algorithm does not understand string values, string characters. Only a couple of them, if you ask me, there are 100 models, only 2 or 3 of them can understand the string values. Other than that, we will have to encode all this string into numeric values. So ML does not understand string. We need to encode this string varchar or char any values to numeric values, and then my model can understand. That is the reason I'm trying to convert this. If you understand me why I'm saying 0, 1, 2, or maybe my encoding method can be different. There are ample of encoding methods, but why we are doing this, what is the reason behind that, you can read the single line. Your model is not going to understand the string, hence you need to encode them, and there are several encoding methodology to understand this. Yeah, this is a concept of random variable. In inferential side, we use different theoretical modeling to prove the situation. What is the use of Python and why Python? Very first and question we should know before moving to learn any technology. Why not C? Why not Java? Why not Scala? Why not other programming languages which follows through object-oriented programming as well as function programming? So definitely I can do them using this typical OOPS concept also. The only question is, or the concern is, I can achieve the same output in 100 minutes, and that too their performance will be very, very low because they follow the typical descriptive style of coding. They do not follow the inferential coding, right? So inferential and descriptive, those are beyond this scope. So I'll not go through on those points, but same code if I'm writing in Python, I can achieve that in 5 to 10 minutes. Now, obviously, being a programmer, being a data scientist or coder or Python programmer, which one you will opt for? You will not go with the 100-minute time and the less performance. Obviously, you'll opt for this because one side I'm writing 100 lines of code, and in second side I may be writing 10 to 20 lines of code. That's it, right? So what you can get through from this point, that Python is having all inbuilt libraries. It's very rich in terms of inbuilt functions, and obviously if you want to do some you want to perform some activity, and for that you do not have any inbuilt functions. So at any point of time you can create your user defined functions also. Python will not restrict you that you can only use my predefined libraries and import them and use them. You can anytime create your own user defined functions also. Yeah, but other than this, Python supports all different kinds of keywords, all different identifiers. We have different input output data points. We have different data types here, like list, tuple, set, dictionary, numbers, integer, complex numbers, different operators. So 7 different operators we have in Python. Then control flow, it follows everything. If else, for loop, while loop, break, continuous statement. File handling we can perform here. Exception handling can be tackled here. And this is a basic Python which you get by default with any Python version. But yeah, here we follow the 3rd generation, which is 3.7, latest version of Python. And guys, the beauty of this, the tool and the curriculum which you're following, this is all open source. You are not following any typical strategy or methods. You can simply go to your internet and ask Google that you want to download Python or you want to read Python. So Python has a beautiful tutorial and their official page. You can visit them and click on whichever version you want to work. So let's say I want to read about this documents. I want to clear my concept first. So there's a tutorial. You can get this tutorial, click on this, and you can see this all the points. So this is absolutely free. If you want to work with any environment, there's the Anaconda environment. You can download them for a single user and use them. If you want to work with the IPython concept, there's a Jupyter notebook. You can anytime create your AWS platform because they also provide you 3 months to 1 year free services. So you can plug and play. This is the open source world. You're not paying a single bucks to anybody. Unlike Oracle and Microsoft, you can get these files, download, and start working with. Python supports the advanced level of libraries, and we have many libraries there to follow our concept on machine learning and deep learning, especially. Library is, first one is a NumPy and Pandas. We are going to use heavily them. Now, what is a NumPy? Let's see the numeric Python concept. So to play with the mathematical values, when I say mathematical values, I'm working with a vector, scalar, one-dimensional data, two-dimensional data, three-dimensional data, n-dimensional data. So this n-dimensional is known as a tensor dimension. So tensor, if you heard about Tensor Flow, Tensor Flow is one framework, one library designed by Google for you can perform them in image processing also. So when we have a huge dimension, so many features on the data, because we human have been evolved in a 3D world. We can understand the 3D information, but we cannot understand beyond that. But how if I'm, because dealing with a 10 dimension, 20 dimension, 100 dimension is very, very normal in machine learning. But how can you understand the 100 dimensional data? Let's say I gave you one data set. So what should be my first approach? I'm not saying that you need to be a technical to answer this question. We need to take the general approach. We receive some data. What will be my first approach? I'll take you that point, but let's go through first libraries and then we'll see where we are utilizing them. So when I want to do matrix multiplication, play with the different dimensional data, and this NumPy is not only used with the Python. We apply them in a computer graphics and in a physics also. So advanced physics, we use this numeric Python heavily. Pandas is good to read the file. So existing file which are already present in my system, such as JSON, CSV, TSV, Parquet. So these are different encryption techniques defined by big data users. Parquet, I can handle Avro. I can run my SQL query. I can read my SQL data, perform my SQL query, perform query on my CSV data. So all these operations we can perform using Pandas. It provides the beautiful data frame, beautiful key value concept, excuse me, dictionaries and couple of other things. Now you can see the number, you can say that I have 1 dimension, 3 dimension, 2 dimension, but we human can see the number but cannot make more sense if I explore those data using exploratory tools. So we have few exploratory tools, like people who work with the Tableau and Cognos, they uses the visualization technique, because if you visualize couple of dimension, maybe one dimension, like using pair plots, you can make more sense other than like different distribution concept, or if you're just taking the numerical values. Because if I give you one data set just to playing with the numerical data or doing mathematical crunching, you cannot achieve anything. So you need to explore it first, and to explore the data, we have matplotlib and Seaborn. There's two amazing libraries given by Python to use different kind of analysis. So I can have a univariate analysis. Univariate analysis, if you understand me, I'm doing only one-dimensional data explorations. One-dimensional data means, in other word, I'll say one column information I'm checking only. Like in typical computer science world, I say one column, one feature, one field, I'll say. But if it is a mathematical world, I'll say one-dimensional data. This is a univariate. You can perform a bivariate analysis also. So bivariate analysis means you're performing your applications on two-dimensional data. So two-dimensional is nothing but let me have a graphical views here to make it more simple. Okay, so say you have one. So in total coordinates, like 360 degree, what do we call a 360 degree? This is my x and x dash. This is y and y dash. We know this is the first coordinate 90 degree. This is 180 degree. This is 270. This is 360 degree. If I'm saying I'm checking my data on two-dimensional approach, which means this is y, this is x, and maybe my data are scattered somewhere here. My data are scattered somewhere here. So I have 4 data points. If I check this particular line, if I check this line, so this line is having one value from y and one value from x. Can I say this is a coordinate of x1 and y1? This kind of analysis is known as a bivariate analysis. because here you can understand how much value of x and y, whether they are going towards the positive direction, negative direction, and just using this concept you can make many analysis. You don't need to really go with the Python and any mathematical concept or strategy. Right. So this is the dimensional thing, and this is a Python, guys. Bivariate analysis, and we can even perform multivariate analysis also. So multivariate analysis cannot be done using 2D technique. You need to have a 3D techniques for this, because three-dimensional approaches, you cannot see here the concept of depth. If I want to visualize my 3D data, I'll say this is my two-dimensional x and y. Be with me, not so good in drawing. So this is y and this is x and this is my z, right? And I'm checking maybe one data point, one difference, distance for this point from the coordinates, z, x, and y. This kind of analysis is a multivariate analysis. Okay. So after Python, let's go. So I know why Python I'm using, because to complete the task, and here I have all ready-made functions available. So I'm not really struggling to write the code and create my own function, sending those data to the less memory area. So here we need to know the different algorithm also, whether I'm looking for time complexity or space complexity. So there's a beautiful approach from data structure, time and space complexity. So using this time and space complexity, I'll write two applications. I'm not going inside of this because this is a concept of data structure again. What application I'm using? So say I'm looking for more time, because over the year, if you have seen, we are this space means I'm talking about the space of RAM. So over the year, we have seen drastic changes on the RAM side. We have seen we have evolved from 1 GB to 2 GB to 4 GB, and nowadays we talk about 16 GB, 32 GB. So this is growing, but we are unable to get the best time using our coding techniques. And here I need to know both application. If I'm looking for more time, that I'm okay with if it is taking more time to process any calculation or perform any analysis, but I do not have much RAM available, much space available, because maybe I'm working with such application which are IoT devices where I have very limited space available. I'm working with the microchips where I do not have more RAM available. So I'm not saying the first approach is better or the second approach is better, where I'm taking less time, but my space on the RAM side is higher. But yeah, again, it is on your hand, which application you feel is suiting with your condition, your approaches, and please follow that. I'm not saying the first one is good or the second one is good. This is just approaches. We need to understand in which application my approach is fitting well. After knowing the Python, let's go and understand machine learning. When I say machine learning, again, I have said I'm converting my manual approach to automation. And here I'm only talking about different algorithmic approach, different algorithms. I can name hundreds of them, but why we are using it, which situation we are using is more important. Supervised learning. Supervised learning, when you have already historical data set available with you, you have historical or batch data. And just like in initial chapter we have seen, if my data volume is more, my prediction rate will be high. We said that at first place. Now, if I have historical data, now it depends. This historical data is from how many years, how many months, how many weeks? Is it 1 year data, 10 year data, 50 year data, 100 years of data of that domain where I'm working? So my prediction, my accuracy, my forecasting will be very, very high. If I have just few years of data, very less data point, I can make a prediction, but my model will be very weak model. So I need to make a good and deployable model where I can predict my business values and actually deploy in the real-time production system. So supervised, where x and y both are known, x and y both are known, and I can tell that they are labeled data. So when this kind of learning is known as a supervised learning, and again it has a two type which I have already written at top: regression technique, which is a continuous problem statement, and classification technique. If you ask me to write the algorithms here, in regression, we have 15 different algorithms. Linear regression, simple linear, multiple linear, polynomial, stepwise, ridge, lasso, okay? There are n number names, but just to naming the names is not really fulfilling our concept, but we need to know every single regression technique, like why we are using them. In classification, there can be a logistic regression, there can be a decision tree. Everyone knows what is a decision tree. It follows the ER diagram. We can work with a random forest. We can work with a SVM, support vector machine. We can work with a K nearest neighbor. We can work with ensemble methods. There they follow 4 different ensemble techniques like bagging, boosting, stacking, blending, cascading, right? These are different techniques from the supervised. But yeah, whenever I say supervised, I am calculating. Regression technique is very plain technique, and I believe we people have gone through the linear maths, and in linear maths we know the formula of line, which is y is equal to mx plus c. In 6th grade, when we have seen this algorithm, guys, we were completely blank that why we are using, but in today's world we can use this broadly to calculate the price prediction, to calculate the inflation rate. Like say I'm checking the price rate of Pune. So what can be the next price in 2021? So I'll analyze all 5 years, 10 years data, and I'll find the fixed pattern, what patterns they're following, and then using some loss and other unit testing techniques, I will get to know one model, and that model will help me to predict anything. Again, I converted my automation into manual into automation techniques. Second, supervised we have seen already, so I'm not going again in this chapter. I'm talking about the second type of machine learning, which is a semi-supervised. So semi-supervised technique can be also known as a reinforcement techniques or reinforcement learning. Now, what is a reinforcement learning here? Where you don't have any historical data, no historical data point. You learn from the real-time environment. So when you learn from the real-time environment, how did you make a prediction, or how did you analyze the scenario, the right scenario, the present scenario, and make a decision based on that? So this is a couple of times known as a decision-making approach also. So this reinforcement is referred with 4 things. First is the agent. So I'll take a scenario where I'm taking example 1, where I want to learn a cycle, So what approaches I need to take if I want to learn a cycle? I'm an agent. I'm considering myself as an agent. I take my cycle. I go to the environment, which I call a surface. So I'll go to environment, which I'm referring as a surface, and I start paddling my cycle there. So when I start paddling my cycle, I call that is my action. So if I'm paddling well, I'm going straight using my right paddling concept. I'm driving well for 10 meters. People who are standing next to me or near to me, they are clapping, and that clapping I'm considering as a reward. So whenever they clap, I feel I'm doing the right thing. When I fall down from the cycle and I do not learn well, they are not giving me any rewards. And likewise, all the learning points I'm collecting as reward, and from that reward I'm learning. So if you have played any computer games, played any computer games, right, such as card games or chess games, so they all are built on the reinforcement learning, because there is no fixed method, predefined method. If you are going to understand the probability or permutation combination, there are 16 different pawns, and we have so many different characters there. So creating the number of permutation combination can take me millions of values, right? So I cannot train millions of values to one model. Rather, I feel that based on the real-time environment, you should learn, and based on that, you have to behave. So that is a reinforcement learning in driverless car. What is this? Driverless car is making the decision based on the real-time approaches. So they're reading how they're maintaining their speed, how automatic car, because you're sitting next to the driver's seat, how the car is making 20 kilometer speed, 40 kilometer per hour, or 60 miles per hour. Based on the decision-making approach, they're reading all the information from GPS. They're checking the rear approach, back approach, left-right approach, and based on that, they make a speed. They know the ETA time. We just need to give the pin of our source and destination. You can talk about traffic system congestion or traffic congestion model. So traffic camera doesn't know that it immediately after half an hour there are 10 cars coming from one direction or 100 cars coming from one direction. So we cannot fit a pre-defined model here. We need to learn from the real-time system, and this is what all is your reinforcement. Couple of this application we are using in the deep learning side also. So deep learning, I'll tell you what is deep learning. Third part and last part of machine learning is a unsupervised technique. Unsupervised learning. Unsupervised learning, you have the data, but this data is completely unlabeled. You don't know what is X, what is Y. You don't know based on what you need to predict what, right? So here we have the technique of clustering and association. This is also known as the associative technique. What is the clustering here first? So when I say cluster, this cluster is nothing but a group of anything is known as a cluster. So if I say there is a 10 different clusters of machines, so I'll say group of nodes, group of machine. I'll say cluster of people. I'll say group of fruits can be a cluster, right? So any group you can call a cluster. So suppose I'm a fruit seller. I'm a fruit seller and I get tons of fruit every day. I'm taking a real time. Again, example where Walmart, retail store shops, they use the same concept. So I'm a fruit seller, I get tons of fruit, and this tons of fruits are having different classes, such as I have orange, I have apple, I have grapes, yeah, I have banana, I have papaya, etc. So how do I categorize them and separate from one big container to the individual buckets that this is only orange, this is apple, this is grapes, this is banana? So I use the concept of clustering here. And clustering, we use the K-means clustering, and we use the hierarchical clustering, and K-means clustering, by just telling you the name. I feel in the graduation time, if you have seen this technique, like in clustering, there's a predefined algorithm where we get every time their centroid and their inertia, and we keep checking them. So it's like if I have mixed values of orange and apple, I'm keep iterating them. Like I'm iterating again and again. So once my iteration is first done, second done, third done, let's say I'm in fourth iteration and my value of inertia is fixed now. So when value of inertia is fixed and again I follow the same approach, and my fifth iteration also gives me the same value, this is the point where you stop your iteration. You say now your values of this, all the fruits are separated using the clustering technique. So this clustering we are using in the banking application, and in banking where we are utilizing them. So in banking we are using them for fraud detections. We have seen already how this fraud detection works. So let's say we actually measure the time. Now in financial and banking profile, we know the transaction time. If you are making one online credit card or debit card transaction, the average time of that transaction is 8 seconds, 8 to 10 seconds. If any transaction is going more than 20 seconds, so we have collected 20,000 data points from the banking industry, and in those banking industry we have separated all 500 fraud detected data. So we know those 500 data points are fraud data, and we are understanding their different approaches, their different scenario. So collecting 500 data points from 20,000 in last 5 years, and I'm training to my model those behavior, that if this is the 500 fraud transaction, in which cases, what scenario this transaction happened, and what all the cases. So my model will start learning from them, and whenever they see the new transaction which are coming with the same pattern, they immediately block it. Or they send you one information that if you're the same person who is using this card, please call on this number to block the card. Yeah, so it actually happened with me. So I have seen it, like we need to call them their branches. We need to say that international transaction please allow, and then they check it. But yeah, it's good point too for the security, because leaking credit card and debit card data is a disaster for the bank. Second, I can say a location. So if I know the location, right? If I know the location that I am transacting one fixed amount, which is 10,000 from Pune, because my base location is this, and I am traveling due to some business work to Singapore. And there again, I'm using the same credit card, Now I have not crossed the 24 hours, and from there again, if I'm using the same card, they can send me one alert that the same card has been operated from India as well as Singapore. So are you the same person? We can use this in the anti-money laundering, anti-bribery and corruption, cross-border payment, like you're transacting amount from India to Syria, Taiwan, uh, Zambia, Algeria, right? There's all the red alert countries, and here your transaction details will come under suspicious activity, and this amount will be have been used for any terrorist funding or any malicious activity. We need to check those points. Transactions monitoring, fraud data analytics. This is all banking domain. In travel industries, how we're using this. So in travel industries, let's say you are a frequent user of Uber and Ola. Yeah. So say I take example of Uber, and if I show you the architecture, like how this architecture is working. So Uber is using these applications at white level, Netflix. There are all new companies, new startups. They all are into this. This is the architecture, guys, and I'll explain you here how we are following this strategy. So we know that there are two separate applications. One is a rider application, and second is a driver application. Right? Rider means we people who book the cab, and driver application. So say at this particular time, 11:15. So 11:15, I requested for Uber, and Uber not immediately accepted my request. Right? Maybe they can take 10 seconds, 20 seconds. So after 23 seconds, my request is accepted. So where my data goes for 23 seconds, because I'm requesting from this application at this time, and driver has accepted after 23 seconds. So this 23-second data will be in a queue, and that queue is a Kafka. If you ask me, Kafka, it's a tool, and this is used by many companies today. Many business banking firms are using Netflix. I hope you guys know the media services. So from one account, how can we see 4 to 5 different videos? This is all possible due to this concept of producer and consumer. So we can follow here the concept of big data: one producer, multiple consumer, multiple producer, one consumer, multiple producer, multiple consumer. So all the concept it fulfills, and it is good for big data because this follows a partitions and replication factor concept. So anyways, let's understand the business. 3-second data goes on Kafka. Once your request is accepted, this gets stored in the platform of Hadoop, or maybe it can be stored in any cloud platform of Amazon Web Services. And later on, we are using this information for the data science purpose. So my end goal is to increase the business revenue, increase the value of my business, so that definitely I should be in a good position always. So how this is happening, how they are using this data to understand their business concept. Let's say you are a frequent Uber user, right? You takes 20 cabs a month. So roughly from office to home, home to office, you take 20 cabs a month, and per cabs you pay them 100 rupees average. And average you take 7 kilometer. Average you take 7 kilometer distance to say you stay at one location and your office. The distance from your source to destination is a 7 kilometer. So every month 20 cabs, 100 rupees. So monthly revenue of Uber is 2,000 rupees from you, straightforward, to 20 into 100. So this is what amount Uber is generating from you. But this month you got your own vehicle and you stop using Uber, right? You stop using Uber. Now Uber will fix their retention period. Uber doesn't know that you purchased some vehicle or you relocated from your base location to somewhere else, but they know two things. That what is your average distance, what's your source and destination, which is 7 kilometer, and what payment method. So they know your distance, and second, they know your payment method, that whether you're using Paytm digital wallet to pay the bill, or maybe you're using Citibank credit card to pay the bill. Now, after 11 days, whatever their retention period is set in their system. So after 11 days, if you do not use their application, immediately they will trigger one alert from their server. And this alert will send over to all the people who have not been used their services for 11 days. suppose I'm the person, so I received this message after 11 days that if you are the same person who is using 7km and Paytm, I received that in my mobile, because they obviously they are targeting the right customer. It's not blindly I'm sending this message to all the people. I need to map the right data with the right customer. That was a problem earlier. We did not have a data and hence we were unable to map. But nowadays I can map with right data with the right customer. We'll see with some other application also. So I receive a message saying that if you travel with Uber before 30th of March, so you can avail 80 rupees cashback on Paytm, and but you'll have to travel at least this. If you have received this kind of messages, this policy is known as a customer retention policy. They try to retain the customer based on their history, what things they're using. So this is not the prediction, this is the analysis. I already have the historical data available with me. I'm checking my server and I'm trying to target this customer. If I'm sending message to 100 people and 10% people also converted, because I cannot say 100% is my conversion rate, 10% we roughly take 10 people converted, so my revenue will go by 10% because they are my existing customer. Second example I can take in a retail shop, or maybe in Amazon or any e-commerce. So retail shop, how this happen again? Same thing happens in the retail shop. You frequently visit there. You visit 10 times there. You purchase 6 times item that is unique. 6 times you purchase something from Nike. It can be shoes, shock, hats, goggle, specs, anything, right? The brand is Reebok. Sorry, Nike. When you purchase 6 times from out of 10 times, it's very clear that this person is more inclined towards the brand called Nike. And based on that, they again start targeting that which card you're using to pay the bill most frequently. And this model, all this model are win-win situation model, guys, because everybody is benefited. You're benefited, you're getting some discount. The mall is benefited because you're obviously purchasing this item from the mall. And second, the bank is benefited because this promotion or discount is only applicable for the card holders who are from HDFC. So everybody is benefited using this technique. I can use this in a chatbot system. I can use this modeling in a real-time system. So real-time state I have seen. I have created one model. I'll display that model. So real estate things we said, right? Real estate booking. What is happening? What is your manual approach? So you are the person, you as a person, you called to any company, which is a Magic Bricks. Okay. And here their executives are sitting. They answer your call. Then again, they call you back after checking their catalog. And they will tell you maybe over the call, they send you on mail and then you check it. Again, you call those executive to fix the deal. So how many steps we are taking? We are calling ample amount of time, like 5 to 6 times. And if there is any cooperation is not done by any of this, so this chain will break. And obviously your time will increase again. So I want to build some automated system. And I want to increase my revenue using this automated system. So what I did, I took 10,000 data point from this company. I created a model. And this model I am deploying. So I'm deploying in some of the website. So maybe I'm saying if you want to check anything, you can go to this website www.xyz.com, or maybe I can fit this model with some of the phone number, some of the toll-free number, which can be 1800XX9062. So this is one number where I'll say, please call. So the moment you call, they'll say, just like a pre-recorded calls when you call to customer care and some phone networks, right? What happened there? Once you call, they say, please select, press 1 for English, press 2 for Hindi. Just like that, I'll say press 1 for area requirement, press 2 for BHK, press 3 for the age of the house, press 4 for the location. And if all the point is good, this is nothing but this is all my X. If this all the value is correct, please click on the submit button, which is my Y. So the moment the person clicks on the submit button, automatically again 2 alert will be transferred from there Two alert will be generated from the system. One will go to the message mobile number of that person who is checking, and second, the same message will go to mail ID. Do we have anybody engaged here? Any executive? And this number can communicate to thousands and thousands of people at the same time. If I take again the scenario, there are executive, and I'm calling this executive as a active person who want to purchase a house. But can this executive communicate at the same time with thousands of people? It's highly impossible by any human. But this model can deal with this. I can fix my number of listener where I can say 1 million people can communicate at the same time. So my time duration delays, as in less time I can deal with a more number of customers request. Only I need to increase my server bandwidth, my RAM, my CPU, my hard disk, which I can do that in a cloud computing era. So this is what we do, guys. This is what is nothing but a modeling. You create the models and you deploy it. I'll show you how this model works actually. So I have created this model and deployed in my Amazon Web Services and one in a DistalOcean. So in DistalOcean, I have one rental system model, and how that rental system model works. So I created this for property modeling. This is again related to real estate agencies. But this is deployed in a website. I've given you two applications. You can either deploy in a website or you can create one toll-free number where people can call on this. This is my model. So this is in some of the URL. I'm using Heroku app. This is a free app. So you can deploy your. I'm saying here I've given the information. This is for people who are non-business user, obviously, right? Or non-technical users. So non-technical users cannot understand if I say please write the value or call the predict method or call the post method or call the get method. That's why I need a good readable UI and good dashboard where anybody can ask any question. So you can fill your requirement of the area, you can fill your number of bedrooms, you can fill your age of property and click on this. This is my X1, X2, X3 because all of these are aggregated of X. And this is my Y. The moment I click on this, after giving this input values, automatically it will predict me one value. This will send over my email. So I'm not calling anybody. This is a cold information. I receive this in email and whenever I need to work on this, I can work. Let's see, let's give this values first. So area I'm giving, say a 1500 square feet, I'm giving just a random value case. 3 BHK and age of that property. If it is 3 years old, it will work for me. So based on my input data set, the rental value of that area will be 2,88,809 rupees. This is based on my input. So what we can conclude here, we do not have any strategy to follow all the strategy, but yeah, just following the right concept, you can achieve the best modeling. And this example can be endless. This example can be applied with all the domain which I have written there in business, how the Netflix and YouTubes are using this techniques. So in Netflix and YouTube, like in media services, if I say, you can fix your genre that I am more interested to watch the thriller series or maybe a suspense web series. Yeah. So the moment you complete first thriller series or the suspense series, let's say you complete the Money Heist. So when you watch this series and complete your episodes, they automatically start recommending you other web series which are from same category, from suspense, which are from same category of thriller. So what is this? This is nothing but a pattern matching. They try to understand the customer patterns, that this customer pattern is more into which site. Same thing Walmart also does. That's why they understand the customer requirements. So today it's not the market that what I have to sell out. Today I need to understand the customer demand to increase my revenue. How Amazon is using this model. So when you go to a shop, I'll write any mall here. And what we do, we go to mall, we want to purchase a shirt from Jack and Jones, right? So I'll visit this shop, Jack and Jones, and ask, can I get a t-shirt? So that their shopkeeper will ask me, you're looking for medium size or small size or large size or Excel size. This input he's looking from me. Once I give this input, then he starts showing me 10 different patterns, right? He start giving me 10 different patterns with a different color, that this is green, yellow, orange, blue. Whichever I like, I grab that item, I go to counter, I swipe my card, I purchase the item, my job is done. But if you're going to purchase this online, www.amazon.in, you go to purchase this from Amazon. Amazon does not have a shopkeeper, right? It's a website. It's not a physical shop. So there is no shopkeeper sitting. So who will tell you, who will give you this 10 patterns? Who will give you this 10 different patterns? Let's see how this is working. So let's talk practically. You go to Amazon site and you click on any. So recently I've viewed on some this images. Let me go again to this same images. So I want to say purchase a mobile, and my budget is less than, my budget is just a second guys. So my budget is 10,000, less than 10,000. Maximum I can invest on this mobile is 10,000 rupees. That's what I am keeping in my mind, right? But this price is beyond 10,000 rupees. So I'm now thinking that this is not in my budget, so I cannot purchase this. If I check other thing, they have a good ratings, they have a good color, they have a good shape, and all the things is good, but only the budget is not allowing me to purchase this. If I check this and I do not like, so I can close this. If I'm closing this, which means Amazon has lost one customer. That's what, you visit a shop to purchase something, you did not find that item, you leave the shop. What is the loss? It's not your loss, it's a loss of that shop, because you did not purchase from there. Now I will tackle this problem with a smart solution. What I did, I created a model. And this model is nothing but a KNN. It's a concept of classification model, K nearest neighbor. Okay, and how this model works, if I explore this data set, so I have Y and I have X here. So my two different data points are scattered here. My two different data points are scattered here. These are my two different data points. This is one class A. This is from some product, and this is my class B. This is from another product. By color, you can see this is class A, this is class A, and this is class B. And randomly, there is another value comes and says this is a new class which you need to label. But how do you label this? How do you label this class? Either you have to make it yellow or blue, but based on what concept? You know, we are using very basic maths. If you ask me, we're using the concept of Euclidean distance, guys. We're using the concept of Euclidean distance. This is a Pythagoras theorem, which we have seen in 9th, 10th, 11th grades. And how the Pythagoras theorem works? Pythagoras theorem says that if I have a height, I have a base, I have a length, so I can calculate any point. Likewise, this point I will check. So in KNN, N and N is the nearest neighbor. This N for nearest, this N for neighbor. What is the value of K? K, I decide how many number of neighbors I need. Suppose I'm giving K is equal to 3. Means from this unlabeled class, they will map 3 data point, which is near. Obviously, it can be 2 of this class and 1 of this class. Maybe 2 of this class, 1 of this class, based on the distance. So simple maths, we'll use distance from this point to this point, because this is also one coordinates of X and Y. So if I check the distance from X and Y, I can get the value. I can check the distance of X and Y, I can get the value, and I can make the distance. So length, base, and height. And H square is equal to L square plus B square. That's what your Pythagoras theorem says. Literally using this plain and basic concept, Amazon has deployed this model here. And you know how much revenue they make. So if I scroll down, I see there are so many other recommendations, suggestions. They say people who purchase this, they watch this also. And I was saying that my budget is less than 11,000 or 10,000 rupees. I get one item there. I get one product there. I can purchase this product. This is coming under my budget now, 10,500, which is okay. Or maybe this product, or maybe this product, or maybe this product, whichever is there, I can scroll it right side and I can get many other items. This is nothing but they are what? They are behaving as a shopkeeper. They try to only give me those data value which I'm searching for. It's not like I'm searching for mobile and they start giving me information or recommendation of air conditioner. This is not happening. When I search for mobile, I only get mobile. When I search for AC, maybe from Whirlpool, I start getting from Kickstart, Hair, Voltas, etc. So this is the k nearest neighbor concept. We apply these techniques to plot this data, and I said k is equal to 3. I'll check distance from 3 nearest point, and whichever is making, so looking at this number, I can say it is near to the blue color, and hence I will make this data point as blue. That's what recommendation does. So what you did, you're not really making any person sit there. And if you ask me how much revenue Amazon is making from this model, you'll amazed to see the number. 38% of the revenue of Amazon is generated only from this model, which we call the Canaan model. You can go to Amazon official page also and read about this information. Okay. Moving on to the next. So we can see many applications here, how we are using this. We know how Uber is using it, how Netflix is using this, how food industries are using this. So there are ample of reasons. Last part is the deployment, guys. So deployment, how I'm doing, and this deployment is done by Amazon Web Services. We'll be using 4 services from there. EC2 I'll apply Elastic Cloud Compute. Here I can create my own operating system, Mac, Windows, Ubuntu, Fedora, Debian, Red Hat, SUSE, XYZ. I can select any number of RAM. So in EC2, I can select any number of RAM, any number of CPU, any number of SSD. These are all my resources. Second service of Amazon which we'll be using is S3, Amazon S3 bucket, simple storage service. So I can store my input file and read from there. We can use DynamoDB. This is a NoSQL concept related more on the big data side, and SageMaker. So let me go through Amazon and give you aws.amazon.com. So let's sign into the console. I'm already logged in. My location is near to Mumbai, hence my server location is Mumbai. So excuse me, we need to set the nearest one from here. If I click on the services, you can get total 152 services are there. So in total, there are 152 services by number wise, but I'm talking about this one where I can use this EC2. I'm talking about S3. I'm talking about DynamoDB. And once I know these 3 parts, then I can go and use the ready-made template of machine learning. So this is the wide area which Amazon support. This is all machine learning techniques. We'll be using this to deploy our model, Amazon SageMaker. We can create a model, we can convert in a binary codes, and then last is the deployment, which we'll do using SageMaker concept. Yeah, so this is how we can achieve this deployment side. After knowing all this concept, the last is how we can connect all of this. So connection means what is the flow? To be a data scientist, what is my initial role? So it's not you are doing all the activity. Actually, 3 teams are involved here. To design any model and deploy, we need a data engineer team. Data engineer are the guy who are extracting the data. They're doing data extraction. They're pulling the data from real-time system. They're modeling those data. Modeling means converting in the best design and then storing somewhere in the warehouse. And from this warehouse or some repository, it is my input point where data scientists will start reading this data. So data scientists will read this data from the system and follow this below strategy. What is the strategy here? I have the source. I will first clean up the data, which is a data cleaning stage. After cleaning the data, I need to encode the data encoding stage. After encoding the data, I need to select the base features. This is known as a feature selection. Base features, when I say, so I suppose gave you total 100 of columns, 100 of columns or 100 of fields, right? And I'm asking you, I don't need all 100 columns. I just need 5 columns to make a model. I will narrow down my data point from 100 to 5. So it's like in machine learning, we call this as a 100 dimension. This is a 5 dimension. So I want to reduce from 100 dimension to 5 dimension. But how do I do that? Do we have any manual technique, any automation technique? And this process is nothing but a feature selection. So you're selecting the base feature. Out of 100, you selected 5 base features, which are helping you to predict the model. After feature selection, then sometimes you need a demonstrated reduction, also we call it DR technique. If there is unlabeled data, you have to work with the feature extraction and feature engineering. Then data preparation, you need to prepare the data. Then data preparation, then model evaluation. So sometimes we end up creating multiple models. We do not just create one model, we create an ensemble model, group of models. Once model is evaluated and we finalize that this model is going to work and its behavior is very good. So I'll predict now using prediction technique, and after predictions, my last part is a deployment. This is my deployment. So this is what we follow. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stage we follow to reach to the deployment site. 80% time this things is going to take. So already at initial talks I said model creating is just a 20% job. The main time any data scientist is spending is this cleaning up the data, encoding the data, feature selection. And then once this is all done, then this is very easy step. So most of the time you spend here. I'll create one scenario and I'll ask you, like, if this is the scenario, then what you guys need to do. Suppose I'm having one flower, right? And I know the flower, I can see the color, I can feel the smell, but I don't know which flower it is. And this flower is coming from a very important data set designed by one biologist, which we call IRIS dataset. And we got this dataset in 1936, before even the evaluation of data science. Now, how this is helping me to analyze or make a model. So this flower is there, and IRIS flower has 3 different types. So type 1, type 2, type 3. I'll not name it because those are biological names. So I'll say type 1 flower, type 2 flower, and type 3 flower. I have plugged type 2 flower from the tree, and then the biologist doesn't know. Biologist is new to this, as in he's working since last 20 years on this field, so he's expert on this domain, but he doesn't know which flower is it. Which flower is it? So I show this type 2 flower and ask to this biologist, sir, can you please tell me which flower it is? Because he's expert from this domain. But just looking at this flower, he doesn't know. He doesn't know. And if you want to see that flower, I can show you that in the Wikipedia. IRIS dataset. Flower dataset. I'll go to this wiki, and guys, this is the analysis of flowers. So if you see this, this is the scientific name of Setosa. We'll see this. This is very common data set followed by many data scientists. Setosa, versicolor, and there is another. This is a virginica. But how do I determine which one is type 1, type 2, and type 3? How do I do that? That's the important question, because I want to build such model which is not a biologist but which will act as a biologist. What is the definition of model. So you are involved in a scientific process where you have written so much of maths, data sets, data point, and you are creating a model which will act as a biologist. Earlier you have seen, I'm not a property consultant, I'm not from the real estate domain, because we cannot, being a human working with any domain, you cannot gather all 100 domains knowledge, right? So if you do not have that domain knowledge, then what you'll do? If you have that domain, it's good. If you do not have that domain knowledge, then please consult with the right person, because just to collecting the mathematical data sets will not really help you. So we need to have the proper knowledge about any data set. What this biologist will ask me, can you please give me a scale and tell me their length and width? So he's asking me, can you tell me what is the length and width of these flowers? I gave the scale, he checked and said, yes, this is type 2. So I already knew the answer, but he also said me, this is type 2, using his expert information, because he knows that if I check this flower, what information is going to distinguish between type 1, type 2, and type 3. Maybe I can ask him, why don't you consider the color? Why don't you consider the shape? But he knows that what is most important. What is most important? The person knows, the biologist knows. If I do the same thing with a banking field, the banker knows what is the important field to calculate anything. So remember, just to collecting the data and playing with data is not helping you. Consider as you yourself as a new data scientist, you receive some data. What is your first approach? First approach will always be understand the domain. Once you get to know the domain, if you don't know domain, consult with the right guy. Second, you need to explore the data. That's what is a visualization technique. So you need to visualize this data, explore the data, and understand how many features or columns are important. So you no need to perform the feature selection if you can explore them well. And this exploration you can do using Python library, which we have seen, NumPy, Matplotlib and Seaborn. Yeah. And third, then you can start cleaning up the data. Data cleaning means you are removing any incorrect info. Incorrect info means you have the integer column, but values you have in that column from string, float, double, boolean. So right column with the right data set. Maybe you have a structural error. Structural error means so much of NN data, so much of missing values, so much of outliers. Now what is outlier? This is all maths, guys. Okay. Just a couple of like 10 minutes only. We will wrap up this session, then we'll have your question if any. Outlier means this is odd one out. So it's like I'm dealing with 50 data points, which are 1, 1.2, 1.6. They are in between range of 1 till 1 to 1.9. But suddenly I see one data which is 50. This 50 is far away from this data point, and this 50 is nothing but outlier. I can say this is odd one out. So this can weak my model, hence I need to perform the cleaning stage and remove all these outliers. We can use fourth technique as a percentile technique. We can use a plot technique. So we're not learning any proving concept. We are learning the different approaches. There is no fixed approach that we have to perform this. You need to trial and error, because it's a combination of many domains. It's not like there is a fixed book that you read that book and become data scientist. We need to use many approaches. Yeah. So this is my flow. This is my flow, and I reach to this data cleaning, data encoding. Already we know we convert that data point from string to numeric values. Feature selection, selecting the best features. So from 100 features, you only selected 5. This is a feature selection. Feature extraction, when X and Y is not known, you have to perform the feature extraction. Data preparation, when you say you are splitting that data into test and train, that's a data preparation. Model evaluation, you create bunch of model, maybe you create 5 different models, but you only finalize one model. So out of 5, you finalize one model, hence it's a model evaluation. Prediction is done, and then last is a deployment. This deployment, which I have shown you right in recently in my one website, Heroku app. So this is a deployment, and deployment needs a different team. So being a data scientist, you are not deploying it. This is done by Python deployment engineer, which are working with a Django and Flask. So they deploy this. Here, I believe I'll stop my discussion just to writing a couple of things like you should have a machine available, because 80% things which we're going to do is completely practical. So I'll be writing like this only. It's not like I open some PDF, read that PDF and share that information. So concept will understand using this plain text paper. All information, if you want to read about our details, you can visit our site prwatech.in/blog. Everything is public here. You can found all the information which is important, which is not. Support system is available here, so you can reach them using the phone number, using some Skype, using a mail. So options are multiple. Your system configuration, I'll say, is at least 4 GB RAM and i3, guys. So this is required, because if this is not there, you can still work, but you'll be terribly irritated that why the system is taking a lot of time to complete to start one service. So if this is not there, you can see how can you increase your configuration. And only one thing, if you don't know Python, people who are new to Python programming, do not worry for this, because when we started working, it was not Python, it was a different programming many years ago. So today it is Python. Maybe after 2 to 3 years, 2023, we see some other programming languages. But what is important to focus here is this: statistics. If you're so good in this, trust me, if you're so good in this, you can search Python library in internet. That's what any developer does. Being a Python specialist also, I cannot remember all the functions, because if I talk about NumPy itself, NumPy has more than 450 functions. How can you remember 450 functions? Is it possible practically? No. You need to have the suggestions, but logic will always be built on this. So 80% this, I'll say, 20% other part. So I feel this all, which was our agenda to discuss as a part of data science demonstration. Any question, if you feel, guys, we can have a word. Varma, you there? Because control is not in my hand, I cannot unmute people. So if you guys can unmute yourself and ask any question. If no question is there from your end, we are good to have. We're good to close the session. So anyone, any doubt? No question? Yeah, I hear something from somewhere. Feel free to ask any question, guys, if you have any.
What will be the duration of this course?
Duration, yeah. So duration will be total, early it will be hour-wise. If I say it's a 70 years of course, excluding the project part. So including that, I'll say 80 years in total. And if it is a weekdays time, if it is a weekdays time, it will be 2.5 months, which means 75 days. And if it is a weekend hours, it is 1 month extra. It is 105 days, 3.5 months. So this is the duration.
Okay.
मिला शायद आपको? अभी भेजा मैंने मेल आपको.
Avik, your voice is interrupting. Can you please mute yourself? Other guys, any other question? So I think you can reach to Avik. Avik will have word with you, and you can ask them, call them. Based on that, we'll see how to start the session, whether offline or online, or however it is, after closing this current pandemic, which we are struggling from. Fine, guys. So I think I should log out then if there is no question. You guys can reach out to Avik, and if any question comes, Avik, please write me down in my mail ID. I'll try to answer as many answers as possible. Thank you, guys.